So far, the rules that we've been using for sequences are called explicit rules. An explicit rule is the kind of rule where if I want the 200th term, you plug 200 in, and the rule gives you the 200th term. Today we're going to look at recursive rules. Recursive rules tell how the nth term is related to the previous terms. So in order to find the next terms, you have to have the previous terms. So recursive rules are nice because they're actually really easy to write, but they're also kind of not nice because if you want the 200th term, you would have to find all of the terms 1 through 199 before you could figure out the 200th term. On your own, I would like you to take a moment, this will warm up your brain, to figure out, ignore this directions, because I'm not going to have you do those directions. I would like you to find the pattern for each of these sequences. So take a moment and A through F, find the pattern. A, the pattern is adding 3. B, the pattern is subtracting 4. C, the pattern is multiplying by 2. D, the pattern is dividing by 2, or as we learned with geometric sequences, that's the same as multiplying by 1/2. How about E? Adding 0 or multiplying by 1, which would make the same number every time because those are the identities. All right, F. If you know what F is before you even looked at this, you don't get to talk. Anybody who's unfamiliar with F, did you figure out what the pattern is? No? Okay, Jude. Say it. Yep. So 1 plus 1 is 2. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 would give you the next term 13. 8 plus 13 would give you the next term. So in this sequence, you add the 2 previous terms to get the next term. This is where recursive rules are really helpful because there isn't a way to write this as an explicit rule. Each term depends on whatever the 2 previous terms were. This is called the Fibonacci sequence. It's the name of a dude. And people who study math, people who choose to study math like for their line of work, for their life, you know, kind of like me, we really like the Fibonacci sequence because it is mathematically beautiful. It shows up in so many places, it's mind-boggling. If you take a flower and count its petals, it is usually a number on the Fibonacci sequence. So flowers either have 1, 2, 3, 5, 8, or 13 petals, or another number in the Fibonacci sequence. If you take each term of the Fibonacci sequence and divide it by the previous term as you continue through the Fibonacci sequence, that number approaches what we call phi, which is this symbol. And for those of you who have asked me if I have a tattoo, this is either my tattoo or what I would get as a tattoo because I'm still not going to answer that question. But phi is related to the Fibonacci sequence, and it's basically how math is visible in all facets of nature. The length of your face divided by the width of your face is the golden ratio phi. It's everywhere. So the Fibonacci sequence is like mind-boggling to people who adore math. All right, we already talked about the difference between explicit rules and recursive rules, so here's just a recap of that. An explicit rule, if you want a certain term in the sequence, you plug that number in and it gives you that term. In a recursive equation, it tells you how the nth term is related to the terms that come before it. So you have to have the previous terms in order to get the next terms. So here's two examples of recursive rules. With recursive rules, they always start out with either your first term or sometimes, in this case, your 0th term. Yeah, 0th. That's a 0th term, whichever pronunciation you want. So the 0th term is 1. That means like the term before the first term is 1. Then in blue, this tells us how the nth term or how the next term is related to the previous term. And what you really need to know is that this symbol, a sub n minus 1, notice the n minus 1 is in the subscript. This symbol basically means the previous term. This is the term that comes before a sub n. And really, if you take a recursive rule and translate it into English, it's not difficult at all. So if we take this and call this symbol the previous term, the next term equals the previous term plus 4. So all we're going to do for this sequence is take the previous term plus 4 to get the next term. So previous term is 1. 1 plus 4 is, not all at once now, 5. To get the next term, we take the previous term 5 and add 4. That gives us 9. To get the next term, we take the previous term 9 and add 4. That gives us 13. To get the next term, we take the previous term 13 and add 4. That gives us 17. To get the next term, you take the previous term 17 and add 4, and that gives you 21. And to get the next term, you take the previous term 21 and add 4, and that gives you 25. They asked for the first 6 terms of the sequence, and technically, because we started with the 0th term, 1 isn't part of that. So the first 6 terms would be 5, 9, 13, 17, 21, 25. But on an assignment, if you started with the 0th term and wrote just the first 6 numbers, I'm totally fine with that. I'm not going to be picky. Number 2. First, they tell you that the first term is 1. Then they tell you to get the next term, you take 3 times the previous term. So this statement says 3 times the previous term. So on your own, I would like to see if you can come up with the first 6 terms of that sequence. 3 times the previous term. So our previous term is 1. 3 times our previous term 1 is 3. 3 times that would be 9. 3 times 9 would be 27. 3 times 27 is 81. And 3 times 81 is 243. And that gives us the first 6 terms. Starting with number 2, to write a recursive rule, the thing that most people forget is that you have to tell whoever is looking at your paper where to start. So our first term is 8. You have to write that down and specify, hey, your starting point is 8, because you can't do a recursive rule unless you have the previous term. So if you don't give them a starting point, they're dead in the water. I like to write my recursive rule underneath the first term. You can write comma and then continue on the same line the way that they did on the previous page, but it just looks nicer if you stack them. Okay, what is going on in this sequence? What pattern do you see? How do we get from 8 to 28? Add 20. Is this adding 20 every time? Looks like it. So could we say that we're taking the previous term plus 20? Does that make sense for what's going on in this sequence? Okay, the symbol for previous term is a sub n minus 1. And then what's happening? We're taking the previous term plus 20. Done. Number 1, it looks like we're decreasing, and it turns into fractions, so that means we're dividing or multiplying by a fraction. If you don't know what that fraction is, take the second term divided by the first term and change that to a simplified fraction in your calculator. We are multiplying by 2/5. Every recursive rule, you have to give a starting point. Our starting point is 100. So our first term is 100. Make sure you get that written down. Underneath, let's describe what's happening. We are taking our previous term times 2/5. When you're multiplying, it's a good idea to put the multiplication in front of the symbol for the previous term. But if you wrote something like a sub n minus 1 times 2/5, I wouldn't count that wrong. It's just not quite as pretty. And that's it. We are going to look at recursive rules for special sequences. Mainly we're going to look at number 1. We're not going to spend time on number 2. Number 1 is the Fibonacci sequence that we looked at before. And with the Fibonacci sequence, you have to take the 1 and the 1 and add them together to get the 2. So because it requires you to use the previous term and the term before that, you have to start by telling your reader, hey, the first term is 1 and the second term is also 1. This particular sequence is dependent upon the 2 terms that come before, so you have to at least give 2 terms as a starting point. Okay, the nth term is the previous term plus the term that comes before the previous term. So if n minus 1 is the previous term, what would be the term that comes before that? N minus 2. So a sub n minus 2. This is the recursive rule for the Fibonacci sequence. This symbol basically means the previous term, and this symbol means the term before the previous term. So a sub n, the term that comes before a sub n is the previous term, and the term that comes before a sub n minus 1 is a sub n minus 2. Oh, that's the answers for yesterday. Hold on. This is the assignment for today. Page 477, numbers 3 through 8 and 11 through 14. Have fun.